Okay, so next topic we are going to start is the boundary layer separation. So what actually is this boundary layer separation? I have told you about what is boundary layer and how this boundary layer develops. Okay, so we have seen what, suppose we are having a flat plate and air stream is flowing across it, so a boundary layer is developed. Okay, and in this boundary layer, if we move in transverse direction, the pressure del P by del Y is nearly equal to 0. That means the pressure remains constant in this transverse direction. That means at any particular point, if I see at in whole this region, the pressure will be constant. Okay, but what about pressure change with respect to x-axis? So with respect to x direction, in x direction the pressure change depends upon the shape of the body. What is the shape of the body? Now what about the change in pressure in x direction? So whether the pressure changes in x direction or not, it depends on the shape of the body. Okay, if the body is a flat plate, as in this particular case, then the change in pressure with respect to x direction is also nearly equal to 0. That means pressure remains constant in case of flat plate. Okay, but if the air is flowing through a curved surface, okay, through a curvature, suppose we are having a sphere like this, okay, and the air is flowing across this sphere. Okay, so in this particular case, just understand this thing very carefully. From this region to this region up to this particular point, the pressure will decrease. Okay, that means at the front end of the cylinder, for this curvature the pressure will decrease, and for this curvature the pressure will increase. That means minimum pressure we will get at this particular point. Here the pressure will be high, here the pressure will be high. Okay, so here the pressure decreases in this region, in this particular region del P by del X pressure is decreasing. That means del P by del X will be less than 0, and in this particular region del P by del X will be greater than 0. Okay, so now what actually is the impact of this change in pressure with respect to x direction on the boundary layer? Let us understand this. Before that, let us understand the impact of this change in pressure on the velocity profile. Okay, so what will happen to the velocity of the fluid? Because in this region the change in the pressure is continuously decreasing. That means here we are having a high pressure, here we are having a low pressure. Okay, the air stream is flowing in this direction. Okay, now because the pressure difference is created, high pressure and low pressure, so an accelerated flow of air will be in this direction, because the air always flows from high pressure region to low pressure region. So the flow will be accelerated because of this pressure difference. Getting this or not? Similarly, when the air is flowing in this region, because here we are having low pressure, here we are having high pressure. Okay, so there will be a reverse flow because of pressure difference. Obviously the stream of air will flow in this direction only, but because of this pressure difference there will be a reverse flow. Okay, so this is actually the favorable pressure gradient. This is the favorable pressure gradient, and this will be the adverse pressure gradient. Okay, so what will be the effect of this pressure gradient on velocity profile? Let us understand this. Okay, so first case we are taking when del P by del X is equal to 0. Okay, del P by del X is equal to 0. That means a flat plate. In case of flat plate. Okay, so when del P by del X is equal to 0, this is velocity, this is with respect to y direction. So we will get the velocity profile like this, as we have already seen. This is our velocity profile. Getting this? Okay, now what will happen if we are having a pressure difference such that del P by del X is less than 0? That means the air is flowing from high pressure region from high pressure region to low pressure. Okay, so what will happen? So obviously the velocity will increase because the air will rush from high pressure to low pressure region, so velocity will increase, therefore the steepness of this velocity profile will be more. Okay, therefore this velocity profile will be somewhat like this. the stiffness is more. Now you will say how the stiffness is more. So because the just look at this curvature and this curvature, and we have to see the steepness with respect to y direction, not x direction. Getting this or not? Okay, so with respect to y direction, the velocity, the steepness of this velocity profile is less, and with respect to y direction, the steepness of this velocity profile is more. Okay, so when del p by del x is less than 0, the steepness is more, and we will get velocity profile like this. Getting this or not? Okay, similarly, when the air is flowing from low pressure region to high pressure region, this is low pressure to high pressure region, then del p by del x is greater than 0. Okay, now what will happen? So when the air is flowing from low pressure region to high pressure region, the stream of air of course will flow in this direction, but because of pressure difference there will be a reverse flow, and because of this reverse flow the velocity of the flow will decrease. Okay, and for a certain region that flow will be in reverse direction, the velocity will be negative. That means we will be getting the velocity profile like this. For a certain region, reverse flow, after that like this. Okay, this is called as the reversed flow, negative velocity. Why is this happening? Because of the reverse flow, because the air is rushing from high pressure region to low pressure region. Getting this? Okay, so these are the three different velocity profile with respect to pressure change when the pressure changes on the surface of the solid. Okay, now coming to the curved surface, and let us actually understand how does the boundary layer separation occur. Okay, so suppose we are having this curved surface like this. Okay, now as I have told you, in this particular region up to this point the pressure will decrease, and after this point the pressure will increase. That means lowest pressure will be at this point. Okay, so if I draw the pressure variation in this, that pressure variation will be like this. At this particular point the pressure will be minimum. Getting this now? Okay, and in this region del p by del x is less than 0, and in this region del p by del x is greater than 0. Clear? Okay, so how will be the velocity profiles? So as I have told you, in this region when del p by del x is less than 0, the velocity profile will be like this. Okay, now this is the point of minimum pressure, and after this the pressure will start increasing and velocity will start decreasing. So at a particular point the velocity will be 0, and from that particular point the separation will start, because the velocity is 0. So boundary layer will start separating from the surface, and another boundary layer will develop. How that boundary layer develops we will tell you. Okay, so at this particular point, suppose at this point here the velocity profile will be somewhat like this. Okay, and after this point now, so from this particular point the separation starts. Okay, so here we were having a certain boundary layer like this. So this was our first boundary layer. Okay, but after this point, because the velocity becomes 0, so this boundary layer will be separated from the surface, and another boundary layer will develop like this. Getting this now? Okay, now if I draw the velocity profile at this particular point, so how will be the velocity profile at this point? So because in this region del p by del x is greater than 0, so the velocity profile will be like this. Getting this? okay, because after this particular point, after the point of separation, this point is called as the point of separation. Okay, after this particular point, there will be a reverse flow, and the velocity profile up to a certain point is negative. Okay, and if I join all the locus of all these points in different profile, if I join all the locus, I will get this boundary layer. Getting this? Okay, and because of this pressure difference, here we are having low pressure, here we are having high pressure, so there will be a reverse flow like this. Getting this? Okay, so this phenomena is nothing but the boundary layer separation. This is nothing but boundary layer separation, and the point from where this separation occurs is called as the point of separation. Getting this now? Okay. Okay, so what is actually will be the impact of this boundary layer separation? Because of this boundary layer separation, eddies will be developed. Okay, because this at this particular point the boundary layer left the surface, and we are getting another boundary layer. So at this region, you can see there will be eddies developed, and this eddies is actually undesirable, and because of these eddies the energy will be lost. So we should opt for the methods through which we can avoid this boundary layer separation. Getting this now? Okay, so now we will look at the methods through which the boundary layer separation can be avoided. Okay, now how can this boundary layer separation can be avoided? So very first method is the streamlined shape of the body. Okay, if a body is given proper streamline shape by changing the radius of curvature, okay, then up to a certain level we can avoid the boundary layer. Okay, second point is that of the suction. Now what actually is this suction? So basically, suppose this is our airfoil, okay, and the air is blowing across this, and because of this there will be boundary layer separation. Okay, and this boundary layer separation is actually because of the loss of velocity. As the air is flowing across this, the pressure in this region is increasing, okay, and because the pressure is increasing, the velocity is decreasing, and at this particular point the velocity becomes equal to 0, and the separation will start from here. Okay, so in order to avoid, and that actually is basically because of the layer which is in contact with the surface. We have the layer which is in contact with the surface whose velocity is continuously decreasing because of friction from the surface. Okay, and because the velocity is decreasing, and because of the change in momentum, the next layer is giving its velocity, and that is also losing some kinetic energy. In this way the whole stream is losing the kinetic energy, and the whole stream is having the lesser velocity. Getting this or not? Okay, so in order to avoid that, we can use one thing. We can make a hole here, okay, so that the stream of air which is losing its velocity, okay, that will, instead of transferring its momentum to the preceding layer, instead of transferring the momentum, it will sink in this particular hole. This process is called as the suction. Getting this or not? Okay, so this is called as the suction. So I will draw the figure clearly here. Okay, so the air after losing its energy will drop on this, like this. This process is called as the suction. Okay, and that process is there, that is called as the blowing. This suction and blowing are very important process, and these are generally successfully used in design of airfoils in aeroplanes. Okay, now what happens in this blowing? So this is in this blowing as well, we are having a space here, and from here we are giving the high velocity fluid. Okay, so as the fluid comes with a lower velocity, this is accompanied by this fluid with a higher velocity, because basically we don't want the velocity to get lost, otherwise it will be it will lead to this to separation. So before losing the velocity, we are transferring the momentum, the high velocity momentum from the stream of air which is passed here separately, and through this we can avoid the boundary layer separation. This process is called as the blowing. Getting this or not? Okay. Next process is acceleration of fluid in boundary layer. Okay. So this is almost similar to that of blowing. So what we do here is, okay, we make a cavity like this so that the stream of air which is coming here, some part will flow here, so that the air which is coming here will lose its velocity and it will gain its velocity because of the air which is entering through this hole. Okay, so what we are doing is we are accelerating the fluid in between so that the separation does not occur. Okay, so this is the acceleration of fluid in boundary layer. Okay, one more method is there, that is by providing rotating cylinder near leading edge. Okay, so what we can do here is we will provide a rotating cylinder. Here we are having a airfoil. Okay, and we are providing a rotating cylinder which will rotate in the direction of the air flow. Suppose air is flowing in this direction. Okay, so this is rotating in this direction clockwise. Sorry, and because of this rotation, a Magnus effect will be produced, and because of this Magnus effect, this stream of air will stick to the body of this aerofoil throughout. Getting this or not? Okay, so by providing a rotating cylinder also we can avoid the separation. So these are all methods through which we can avoid boundary layer separation. Getting this?